So, Danny, why don't you go ahead and take it away?
Yeah, and actually, someone asked a question that is a perfect way to start it, because this question is the reason I asked is because I actually still don't know where you can actually use pure ECS and where not, like audio or particle systems, for instance. I really haven't looked, and the
There
thing
you
about
go.
this project really shows where you use one and where you can use the other, and how you manage the two together, and what you need to think about in order to merge the two. Um, but for a quick overview, I actually wrote down the description of this entire project and how it was set up and the thought process behind it. Stuff like the very first thing that I'll be showing, and this is, by the way I'll be doing it today, this presentation, is I will give a quick overview of how I went about tackling this. Now, note that if you actually go to look at the commits, some of it is in a slightly different order, and that's because a lot of this is figuring out as you go. Oh, hey, now I need audio. How do I figure that out in ECS? And then it might not align with what you initially planned. But the first thing I did for this project is I simply went ahead and I got the asset. In this case, it's Kyle from the asset store. And then I figured out which part of that asset do I want to make interrupt version 4 and which parts do I not want, and then like just simplify it a lot. And I'll show in a bit how I simplified it. And it also says here some of the things I did to simplify it, along with the specific changes. And then I'll be showing how you can build an animation interrupt, because animation is one of those cases that is currently not supported, like particles and audio. But there are ways around it, and I'll be showing that. Like, one of the two things that you have to consider, at least in my book, when you design for managed interrupt, is whether you're dealing with case A or B, which is whether you have a managed behavior that is really tied to a specific object, like for instance, the vehicle, a vehicle moving around, and there's audio to it. That audio sound is tied to the specific object. Or you have something like UI or input, where it's more tied to the fact that it's in a scene. So yeah, there's just some general overview here, and obviously I'll be showing that in a second, how this actually comes into play and how I set up the animation. Then it's also about importing the character controller and making sure that it, integrates the animation, and it ensures that there is like an orbiting camera with physics collisions. Yeah, and then I'm gonna simply, what is it? Yeah, implement the specific animation so that when I move around, it actually does the animation and doesn't just stay a static thing, and also the animation events. So that's the general workflow for today. And yeah, the first thing I'll show is obviously with any asset, you first go in here and press, I want to get this asset. That way it can show up in your package manager, my assets, robot Kyle, and then you can import it. And then when you go to import it, it will ask you to get a Cinemachine, and then it will show a giant pop-up like this of all the assets you want to import to the project, which I went ahead and did for this showcase. So I've already imported that, and I also already imported something else that we need for this project. Because we also want Philip's amazing character controller, which you can see in the Unity registry. There's a character controller, if I know my spelling. There, yes. And something we also need is the standard character samples. And that's because the character controller, and I'm sure Philip would be able to correct me if I'm wrong, is really designed for having a specific set of utility functions that enable you to build your own kinematic character controller. And then the sample is just a showcase of how you could implement one of these, like all of the API needed. So stuff like checking whether there's a collision with the next thing, or what happens if I hit the ground, or stuff like that. There's a lot of utility functions that the package enables, and then the standard character is just an implementation of one of these characters. So yeah.
Yeah, because if you have 100 different projects, there's probably 100 different best ways to structure your character, and or like to decide which features you want your character to have. So that's pretty much the reason why a lot of this code comes in the form of a sample that lives in your project code, is so you can hack away at it and just rearrange it however you prefer.
Yes. and we'll show in a second how to get a character moving. Once you import the asset store Kyle, one of the first things you will probably notice is that you get a scene, and this is the playground scene. And if you open that and press play, you immediately have a character that is moving around and works. Obviously, this is just using the standard character controller, not any dots thing. In order to make it dots compliant, we sort of have to clean this out a little for things that doesn't really work that well for dots. And a nice way to see what works and what doesn't is simply just create a subscene, call it something over like overworld. And then what happens if I take my player that lives right here and I plop it into my subscene? Oh, I get errors. Okay. Like cross-scene references. Okay, so it's saying that the player can't reference anything in here, so I need to remove anything that is referencing anything outside. And what else happened? Well, it's laying on the floor. And that's because generally, obviously, this character here has a mesh on it. And we can see that mesh right here. And that's an animator. And then we scroll down a little. And then there's a skinned mesh renderer. The skinned mesh renderer will actually be baked to something. If you look here, it is getting baked, which is turning that game object into an entity. Now, the thing is, it currently has a material on it that is not supported by the dots skinned mesh renderer. So if you want to draw a skinned mesh, you need a specific material in dots. Now, the shader that you need is simply one that contains a specific node. This node is, if it will let me load up, the linear blend skinning. And you simply pass it into the vertex part here, and Bob's your uncle, you now have something that works. And if you want textures to work, you have to do classic shader stuff, but that's besides the point. It means that I can go into Kyle and I can simply find the mesh and find the material, which this mesh has, go in, say shader graph, and he's standing up. Okay, so we fixed that part. So now we at least have a visual representation. Clearly, there's still all of these cross-scene references, so let's get rid of some of those simply by looking at the character, going through, realizing why is there an animator here when there's already one there. So you could go ahead and remove that. You can remove some of these other things. And I will actually move on later to show if you go into this here, it specifically says the changes I made in order to simplify it. I'll skip ahead because otherwise I could be here for a little while extra, and we don't have time for that. So just imagine you simplify this out and fix all the cases that caused these warnings, like cross-scene references and stuff like there's a player input managed component here. And one of the ideal things you really should be doing here is you should go to the asset, because this is using the new input system. So if you want to make the new input system work with dots very well, instead of having to do all this like baking process and navigating around that, we can actually just ask it to generate a C# class, call it something like Kyle input, because otherwise the other word is already used. Then apply, and then now we have a class that we can use in our dots code. And then again, you go ahead and re-implement it in this and check and validate that this character still works when you plop it out here. Now, another reason that I did this is that when we go to the animation section, we will need to still show him as a prefab. But I'm going to go back to that in a second. Now, the next part of this is making sure that, and I wonder why there's a domain reload. Come on, be done. Is to make sure that we have implemented his character controller as it comes out of the box when I pressed import samples. So when you go and press import samples on his character controller, you will immediately get this samples folder, and I cannot see what is behind one monitor to the next. Okay, there. So if we go, there's a standard characters folder, a first-person controller. We don't need first person in this case because this is a third-person thing. So let's just delete that. And I'm fairly sure that things still compile. Because that's an implementation of a first-person character controller. One thing we can note in the meantime is there's something called an orbit camera, a third-person character, and a third-person player. An orbit camera is simply the entity that is going to represent orbiting around our main character. So that's similar to how in this project with Kyle, there's a player follow camera. It will also the player follow camera is a Cinemachine version of the orbit camera. They're exactly the same thing. Well, sort of. Another nice thing with the orbit camera is it has default behavior for colliding, like what's it called, obstacle avoidance. So it zooms in if there's a thing in the way. Also, why did it zoom down? Yeah. So if I quickly go ahead and take all of these things, plop them up into the overworld, then in order to get this thing moving, looks very ugly, I simply take the orbit camera. I look at it and consider probably nothing needs to change here. Then you look at the third-person player. This one is going to tie the two together. Essentially, it's going to make sure that our input system takes the input, puts it here, and then it will move around the character. So which character is it going to move? It's going to move this character. Which camera is going to move around this target? Well, that's the orbit camera. So basically, it just ties these two assets together. And I do wonder why Philip did exactly this, but I'll ask him that in a second so I stay on track. Because I think already now we should have something that moves around. So if we go, let's play. Oh, wait, okay. I should probably make sure to disable this guy in the meantime. Boom, boom. Oh, and one thing I forgot to do, and Philip probably remembered this as well. Currently, we just did this, which is just a bunch of entities. Obviously, there's still a camera that has to move around, and a camera is a managed object. As soon as I put like if I were to take this camera and put it down here, it just wouldn't work. Like it will complain at me. I'm surprised that it basically didn't complain, but it does complain. It's supposed to complain. So one thing we do have to do is we have to tie this entity that is moving around to the transform of the camera, and the sample already has a thing built in for that. If I quickly remove the Cinemachine brain, so Cinemachine is not the one moving the camera. There is the game object camera object here, which basically just does a singleton so that a system could ask for this singleton to exist. And then if we go into the orbit camera and then do main entity camera offering, this will ensure that what's it called? It will set this entity. No, it will set the camera to match the entity here. So there's a system constantly running, making sure that it finds the camera and then sets the camera based on this orbiting camera. And now what we should see is that we're falling through the world. Obviously, this is because there's no environment. The environment is still in game object land, so even though we can see it, it's still in game object land. So let's just plop it down. And one thing we'll notice, again, a bunch of errors appear. Why is it this time? Well, something that is unsupported is having null meshes, and you can clearly see there's a bunch of null meshes. So let's just delete that, because those overlap and aren't actually needed. Otherwise, you would need to fix null meshes. But now what we should be able to see is that our character moves around, and I can jump, and it all works together, which is very nice. So now I have a character that moves around, still not animated, but we can see what we need to do in a way in order to get this animated. Because just like if we look at the player armature, you sort of have this top level thing that controls the character, and then underneath there's the actual geometry. In the same way, this is also a top level thing that has the actual character and the behavior attached to it. And then underneath it has the geometry. And in this case, it's a capsule and another cylinder, which is this part. So we simply need to replace this with our actual Kyle asset. Now, there's also a camera target, which is the thing that the orbit camera moves around. Now, there are some annoyances here, like the fact that this still has an animator up top and it has the animator down here. I'll do some simplifications on that, and it's described in here, but I'll quickly move on by just skipping ahead. I think I first need to save here so that it reloads properly when I switch over. Yeah. Force checkout. That way we can fast track. So the only thing that is going to happen now is I didn't do any behavioral changes. Remove the mobile UI. I removed the URP wizard that comes with the asset, the Kyle asset for some reason. The ability to push objects. I changed the input system. A bunch of like small changes. The store asset comes with URP settings already. It has Cinemachine. We're gonna not use Cinemachine. Stuff like that. So when we go to reload, in a sec, boom, boom. What we see here is I basically removed the character that we had before, the game object version of the character. And because we don't need him, because the rival character is gonna be dead. And then we're gonna replace the capsule with the actual animated character. Then I also moved in the environment into the subscene, and notice how we now just have the orbit camera, and we don't have that little extra asset anymore. We just have that inside the third-person character offering. So now it's the case that the control camera is here, and it knows that this will make sure to set up the orbit camera to move around the target, which is down here. It's a very simple asset. So it doesn't do anything more. So this will ensure all of this is hard to explain, but the capsule collider will make sure that we bake all the components needed for physics to work. The third-person character offering is a custom setup to get our character offered both all the parts that have to be part of the rival character controller, or what is now known as the community character controller, but also extra stuff like walking speed, sprint speed, etc. And then camera target simply adds the camera target. And so this is one of the nice parts of baking. Normally, this offering workflow would be a fucking mess if you wanted it split up as much as this, which is the more optimal approach in a way, because it's going to be linear in memory. But because we have this little nice baking offering workflow, we can just like changing the speed around. What does this value change? Well, it changes the thing called a third-person character data, which I am very blind. Third-person character data is somewhere. First-person character input data. There you go, which will ensure to, in this component here, store all the additional data that we need, like walking speed and sprint speed. I'll be showing code later that actually goes into detail on how we use these components. But just know that this offering workflow here has a baker that will ensure that we get all the components we need for the rival character controller. So we have the environment, we have a camera that moves around a character, and we need the mesh to work. So how do we want the mesh to work? This being the next part of the setup. The building animation interrupt. And obviously, if I'm going too fast, I know I was going to go fast today because there's a lot to cover here, but that's the reason this document is here, to sort of help you catch up and get some of the main points in. Because here's the thing, we need to do two things here. In play mode, what we want is there to be a game object, and for that game object to move around with our entity. One of the normal problems I could have is, well, I'm dealing with case A here. I was splitting up the two cases earlier to a specific object or whether it's tied to a scene. In this case, we have case A. And that means that if we want a workflow where the scene is going to be the owner of the game object, which is what I generally recommend, the system that you have be the one that moves around your game object, then you obviously need for the system to get a reference to the game object in the first place. Now, it's going to be very annoying if you had to have something like the main camera approach here, and then get a singleton for that, and then tie it down. Especially if you had more players, then a singleton wouldn't work. Then the singleton would have to be an array, and then the systems would have to figure out after the fact how to map one entity to one game object. Instead, what we're going to do is we're going to have our entity be the one that at runtime, as soon as I hit play, spawns a game object. And then when it spawns the game object, because it's the system that is going to spawn the game object, it will be able to already have the reference. And so it can add components to itself and do a lot of nice stuff. So if I hit play right now, and this, by the way, is the full implementation, then you can see that things are moving around. And the reason for that is that, as I said, I hit play, and Kyle robot with events spawned, which is a game object. So we have this little game object, and it just is the model that we saw earlier. It is the Kyle model. And it has the robot Kyle mesh that we saw earlier, and it has the root bones, because that's what is moving, the animator is moving around. How is this tied to the entity? Well, if we look at the entity itself, and we look at the baking preview, we can see it actually has a Unity Engine animator on it. Because the thing here is that we have this concept of managed components, and managed components are not only iComponent data of class, they are also any Unity Engine object. So you can actually attach a reference to an object and a specific component directly onto the entity itself. And I'll show in code how you do that. But just know that our component right here, our entity can say get component animator, and then it will get the animator that points to this spawn game object. Which means that if I were to do then get that reference and do set speed or any of the other, like set float, set spool, set vector, etc., it will make changes here, which is also why we can see a full debug view like we're used to with the authoring workflow. So we can actually see it moving around. And as soon as I exit play, it deletes the game object. And there's another reason for that. Though something to realize here is I said that at runtime we are spawning the game object, which means that in the editor there wouldn't really be any visual representation of it. Yet here we do see that there is a visual representation. Like if I move this around, then so does Kyle. Now this one is actually not important for that specific part. It's actually this one. There's an animator offer. It's just a mono behavior that is pointing to the prefab that is the game object. So if we open up this prefab, this is the actual game object, the one that is going to be spawned at runtime normally. But because we know that this prefab is actually also valid as an entity, like if I put it in as an entity right now, it's going to show up correctly. What we can do is we can have an editor system, and we had a previous episode, I think it was like number 7 or something, where we showcased how editor systems can help you show things in the editor. So what I'm doing here is I'm making sure that when I'm in the editor, I'm just going to spawn the entity prefab version of it as my visualization. That also means that if I go into the entities hierarchy, so we can actually see any of the entities spawned at runtime, like right now I'm in runtime representation, and we then go to look at Kyle animator, instead of instead of Kyle animator just only being the entity itself, it has spawned a prefab and then set the parent of the prefab to be itself. So like when I go and move around this thing here, which is what I'm going to move around when I move this around, then because Kyle robot within events is a child of it, it will move around with it. And that's why moving around here actually shows something in the editor. Now this sounds like a lot of setup and actually very difficult to do, but it really is not that bad if you squint at it, and I'm also very biased. And this is where I'm going to show off the code for the first time. And any questions so far?
There are a couple coming through. Do just want to let you know real quick that we do have a hard stop at the top of the hour here. We've got to get out of this room here, so just kind of heads up on timing wise that way. So if you want to show anything off in the code, and then we can hit some of these questions that are coming through here.
Yes. Yeah, I'll try to get through it real quick. Good. So to bake our little animator here, we have a mono behavior that is obviously referencing the animator. And if we look at this piece of data, it's a Unity object ref of game object. And the nice thing about a Unity object ref of game object is that I can store a reference to a game object, and it will be put in the scene file. So because this is storing a reference to a prefab, it will have the, as soon as you deserialize this and load the scene, upon scene load, it will make sure that that prefab is available for you to spawn. And so this data here will have the prefab stored on it. And secondly, there will be in the editor something that stores an entity version of this prefab. So we're storing the game object version, and we're storing the prefab version for the editor in two separate components. So when we're in play mode, let's think about that case, which is this system here. Then we're gonna skip this part. This is for debugging. We're simply gonna look for anything that has the animator instantiation data component. So that's the entity that we are wanting to map to our animator, our spawn game object, that does not have an animator yet. So because it doesn't have an animator yet, we want to set it up. Then we instantiate it, we set it, we assign it, and we add the component data. We also add a cleanup so that we can later have a reference to it and then clean it right here, which will make sure to destroy the object. So as soon as the entity disappears, it will also disappear the game object.
I like the name of destroy this animator.
Yes, it's very explicit. And then it also has nifty extra things like the way that I approached the animation events. Because sometimes you also want the game object that you just spawned to have additional references to that. So if we actually went to play mode, it had a Kyle animator events game object on it, mono behavior on it. And if I wanted to reference Kyle animator events, I simply can now add mono behavior to entity on animator instantiation, very pretty name, to my mono behavior. And that means that now, anytime I, have a prefab here, because this references prefab, it will look through all the components on that prefab, checking if it has this interface on it. And if so, it will make sure that our entity that is spawned also has a reference to that. So if we go in here, we can see animator. It's not that one, is it? There. This is the managed reference. So it's a reference pointing to that one. So that means that we can also do get component on that, just as simply as we could earlier. And now it means that we can simply write code like this, where we get, if we have the entity, we can get the animator, and then we can set a bool on it. That is what this code allows us to do. So let's look at the character controller and how that all plays nicely in together. So boom, boom, and I know we are getting close here, but I quickly want the last things in. So samples, yes, person, scripts, and this is the system in the sample that is responsible for taking input from your controller and like turning it into movement on the character. So one of the things that I added is that every frame, and this is this where I did it? No, it's not. Yeah, this is where I did it. So the default sample here shows that there's a system that runs every frame, and there's a system that runs every physics tick. Now, because this is animation related, I wanted to happen every frame based on something that happened in the physics. So I simply, update the default thing that is in the sample, and if you go to download the sample today, it will have this in it, just in a job instead. And then what I also did was, boom, boom, boom. I can now simply get the animator. I can then check which things I need to add to it, like setting a float, setting a motion speed, ID jump, grounded, etc. I'm able to control all of these things because I'm able to get the reference on bake. Yeah, and the way that I then can handle events is I ask, hey, please give me the animation entity as well, because it's also the one that contains the Kyle animator events. And then give me some managed data about the animation. And then ask, hey, do I have a footstep event called? And then trigger a footstep. And then do I have a move land next called? Then do that. And the reason I can do it is because this behavior is just a normal mono behavior that happens to be on this thing.